Hi, welcome to tutorial number 3 in this lecture series on syllogisms and deductive logic. In the last two tutorials, we discussed the basics of syllogisms and Venn diagrams. Now in this one, we will learn the way they are supposed to be done in the exams. So let's proceed. Look at this statement. All A are B. You must remember how we draw the Venn diagram of the statement. There are two possibilities. One in which A and B are equal, and two in which A is a proper subset of B. But now onwards, if we have to draw a Venn diagram of all A or B, as far as these questions are concerned, we will draw this figure. That's the one in which A is a proper subset of B. Means all A is contained within B and B has got some extra elements as well. So this is something that we call the Venn diagram with minimum overlap. Think of it as the minimum eligibility condition for this statement. What's the statement? It says all A are B. So that's what precisely the figure shows. But it omits the possibility that A may be equal to B. So it's the absolute bare minimum condition for the statement. That's why it's called minimum overlap. The overlap that's absolutely required. I hope that's understood. Likewise, look at this second statement. Some A are B. Now if you remember this, there were four cases in this. One in which A and B are equal, two in which A is a proper subset of B, three in which B is a proper subset of A, and four in which there is some partial overlap. This figure. So for this statement, this is the figure of minimum overlap. It fulfills the basic condition that some A are B but does not make any assumptions about what A and B can be. So that's the bare minimum, the minimum overlap diagram. Now whenever you come across a syllogism question and a statement of one of these two types, these are the two figures that should come to your mind. Just draw them without thinking of anything else. Now we'll take an example and I'll show you how we attempt questions quickly using these minimum overlap diagrams. Look at this. Four statements, four conclusions, and the answer options. So that's the question. Let's now make the Venn diagram using the statements. 1. Some bikes are cars. So let's draw bikes first. If this is bikes, how do we draw cars? Like this. So we just show a partial overlap of cars with bikes, the way we discussed a while back. Forget everything else. Go to the next statement. All ships are trains. So this is not a connected statement. Let's draw it separately. Ships first, and now the trains. Since it uses the word all, ships would be contained within trains. So this is exactly what we discussed. Now look at the third statement. At least some buses are cars. This at least does not mean anything here. Remember this. This is same as saying some buses are cars. So whenever you see at least in any of these questions, just omit that. So this becomes some buses are cars. Now cars is already there. So let's put buses here. So here comes buses. Just a partial overlap with cars and nothing else. Now try and understand this. We can extend buses. We can in fact even show an intersection of buses with bikes or with trains. But we don't do any of that. We just show the minimum overlap. And the condition is that some buses are cars. So we just stick to that. Now the last statement, 4. No buses are ships. So we draw something like that. This sign tells us that whatever else you do with the figure, you cannot make buses and ships overlap. That's what that sign means. So basically this reminds us that buses and ships are disjoint sets without going back to the statements. That's why we should always draw it like this. Once you have drawn this, it's very simple to answer. Look at the conclusions now. All cars are trains. What do you see here? There is no intersection between cars and trains. So this is incorrect. Does not follow. 2. Some trains are ships. We can clearly see in the figure that all the ships are within trains only. So this is true. This follows. Number 3. Some buses are bikes. We can see from the figure that bikes are not intersecting with buses. So that does not follow. Number 4. Some cars are buses. Obviously, that's there. We can see it in the figure. So 2 and 4 follow. And our answer would be option C. So basically, if the statements are like this, affirmative statements. We can just answer it very easily looking at the figure in a few seconds without manipulating it, without doing anything in the figure. You just need to understand how to draw this figure of minimum overlap. It can be confusing at times. Let's look at another example. This is it. Let's start with the statements now. 1. Some cakes are roses. So let's draw cakes first. Now the roses. So it's a partial overlap. Now statement 2 says all roses are trucks. So let's draw something like this. So we can see that all the roses are contained within trucks. Now there is something that you should notice here in this figure. When we draw trucks, we ensure that it intersects only that part of cakes that is shared with roses. This is very important. This again follows the principle of minimum overlap. We did not extend trucks to that part of cakes that is not shared with roses. So remember this. You get questions on this. We'll see them later. Alright, let's look at statement 3 now. No trucks are bricks. So basically it says that trucks and bricks are disjoint sets. So let's draw bricks like this. Again this arrow and this cross tell us that bricks and trucks can never overlap. And now the last statement. At least some bricks are hotels. So this is same as saying some bricks are hotels. So let's draw hotels like this. A partial overlap with bricks. So this is the complete figure now. The figure of minimum overlap. Now it's very simple to answer. Look at the conclusions. 1. Some trucks are cakes. Is there an overlap? Yes. It follows. 2. Some bricks are roses. Can we see an overlap? No. So it does not follow. Number 3. All cakes are trucks. So we can see in the figure that some cakes are shown to be trucks, but not all. So it does not follow. And now the last one. Some hotels are cakes. Can we see an overlap? No. So it does not follow. So the answer would be option A. Again, we could answer it very easily just looking at the picture in a few seconds. Let's look at one last example. That's there. Let's go to the statement straight away. All tigers are dogs. Now that's really funny, but let's focus on our job. Let's draw tigers first. Now the dogs. So we can see that all the tigers are contained within dogs. Statement 2 now. Some tigers are cats. So there has to be a partial overlap between tigers and cats. Something like this. Alright, looks good. But do you see a problem in this figure? Look at it carefully. There is an issue. Look at this region, the one with those crosses. This region shows the intersection of cats and dogs but without tigers. So ideally we should not do it like this. Please understand that whatever intersection of cats and dogs is happening should happen because of tigers. Because tigers is the common link between dogs and cats. So basically this violates the principle of minimum overlap. So we can see some part here that's dogs and cats but not tigers. It should not happen. We should remove it. So ideally the figure should be like this. Now there is an overlap between dogs and cats, but that's the same region in which tigers are also there. So only those cats are dogs that are tigers as well. This is very important. Remember this. Let's move forward and look at statement 3 now. All cats are lions. So let's draw lions like this. Again, understand this. All the cats are contained within lions. That's the easy part. But when we drew lions, we ensured that lions intersects with tigers and dogs only to the extent that cats allows. So lions intersects with tigers and dogs only because the set of cats is already intersecting with it. And since all the cats are contained within lions, lions will also have to intersect with it. That's minimum overlap. Please understand that it does not mean that there can be no lion that can be a tiger but not cat. It only means that that's a possibility, not a necessary condition. And in these diagrams, we show only the necessary conditions. Hope that's understood. Now let's look at the last statement. All cows are lions. So it means that all cows are to be drawn within lions, something like this. We ensured that cows does not intersect with cats. They could, that's a possibility, but we do not know, so we don't put it there. So that's minimum possible overlap. Now we can answer the questions very easily. Look at the conclusions. 1. Some dogs are lions. It follows some cows are dogs. It does not follow some lions are tigers. Yes, it follows. Number 4. All cats are dogs. Some cats are dogs, but not all cats are dogs. We can see it from the figure. So it does not follow. So the answer would be option D. Only 1 and 3 follow. So again, this was only about making the correct figure and nothing remains in the question. The most important takeaway for you from this session should be how to draw the diagram of minimum overlap. Take random statements and try drawing a lot of these diagrams. You should be able to do them very quickly and without any errors. If you can do it, cracking syllogisms would not be a problem. Another important thing that you need to know is that in all these three examples, all of our conclusions were affirmative in nature, means all of them were positive statements. So we will have to tweak this method slightly when it comes to questions on negative conclusions and possibilities. The method would remain the same, only a slight alteration in it. So we'll discuss that next time. Meanwhile, do a lot of practice of drawing these minimum overlap Venn diagrams. Happy learning!